Let's start. Hello.
Hello.
I'm Peter and I'm the Java guy. As I hope many of you here, I work in JBoss Fuse team. JBoss Fuse is a product built on top of Apache Camel that you may know. And previously I worked in JBoss EAP team. This is Marek.
Hey, so my name is Marek. I work at Red Hat and I work with the cool stuff called OpenShift and Kubernetes. And I will be trying to be the opposite of Peter today.
So our roles here are really I'm the Java guy who knows how to code Java stuff, and Marek is the cloud guru who is supposed to know everything about bringing Java applications or any other kind of application to the cloud. Our agenda consists basically of three steps. We start with a simple Spring Boot application. We gradually bring it to the cloud, and in the end, there's a substantial part about the deployment strategies. So let's start with the Spring Boot application. It's actually my side project. A friend coming from Austria has recently mentioned that he needs this for somebody working in public administration. This is basically a simple application to schedule horse rides. You can think of it as Uber for horse rides. You can order a horse, and the horse will be delivered at a place, and you can make a ride, and then you give the horse back.
The benefit of the horse is that you can actually let them go to the place. So you don't need any special AI to send the cars there. You can send the horse just
Yeah,
fine.
yeah, yeah. Horses are driving autonomously, so to say, and actually. Maybe the friend who has given me this project thinks that horses are the next big thing because diesel engines are going to get prohibited in German cities. So, or I don't know. So this is a simple Spring Boot application that has just a couple of entities. As here you can see, we have a horse and a person that is supposed to ride on horse. Horses are housed in stables. The stables have some GPS coordinates so that we can schedule a horse from the nearest stable when somebody orders it. And there are, of course, rides that this application is supposed to schedule. The CRUD endpoints are provisioned by Spring Data. There's just one service that is doing something intelligent, and that's the ride scheduling. That is not finished, by the way, yet, but it doesn't matter much. And there's a simple static UI that just lists the REST endpoints. So this is my application. The customer wants us not only to deliver the application, he wants us to run it. So it means we are becoming true DevOps, and it's actually up to us how we run it, which tools we choose, and that's why we actually have Marek here. Marek, so what can you offer in this situation?
Okay, so today everybody is speaking about containers, so I guess we should go with containers. So the first step will be to containerize the application, and once we have a container, we need to run it somewhere. If you use something like Docker itself, it is great for running on single machine, but if you want to do it on a cluster, you need some infrastructure. You need some container orchestration system, and there has been some kind of battle between different orchestrators, but today it seems that the standard is becoming to be Kubernetes.
Is the Java EE standard, you mean?
No, not really. It's a de facto standard of how you actually do containers on a bigger scale. Kubernetes has been conceived by Google, and the two biggest forces behind it actually is Google and Red Hat.
No, but wait. That's a huge thing. How can I start with cloud actually? Because what should I do? Should I order a data center or?
You should definitely order a data center if you can afford it, but not really for today. It's very easy to set up. There is something called Minishift or Minikube that actually allows you to run a single node cluster on your machine. So if you don't want to actually order anything, you don't want to pay somebody to give you some infrastructure, you can do it on your own machine. You just download it from GitHub/Minishift/Minishift. It's a single binary that you run on your machine. It creates a VM. It deploys OpenShift or Kube inside that VM, and you have it running. You can do pretty much everything that you would be doing in the cloud. You can do it on your machine, and that's actually what we are going to use, right?
But wait a minute. OpenShift and Kubernetes. You said there's some close relationship there, but yeah, with OpenShift, am I getting systemd?
Don't worry about it. You don't have to care about that. Essentially, OpenShift is a distribution of Kubernetes. So if you do run OpenShift, you run Kubernetes. You can treat it as Kubernetes if you want to, but you don't have to, and you can use something more high level that's provided there. But it's completely up to you, and we will see.
Okay, so now let's assume I have installed Minishift just right now. What should I do?
Can you make the font a bit bigger? Awesome. Can you read it from the back? Great. So what you need to do is to start Minishift. So Minishift space start. Don't do typos.
Start, and now?
Okay, don't press return yet. So if you would do it, it would spin up Minishift for you, but it will give you the default configuration of resources, which is 2 gigs of memory and one CPU, I think, 20 gigs of space, which is not really what you want. So you need to specify how much memory, how much CPUs you want to dedicate to the VM.
Okay, something like this, right?
Yes, something like this, because this is Java. So 2 gigs, no good.
But it's Spring Boot.
Come on, you will see some cool stuff. So give it some resources. So 8 gigs should be fine. CPU 6, yeah, that's cool, and some disk space. Yeah, just run it.
Okay, let's assume I have started it, because I have started it in the past, because it needs some time to boot, so I just cancel it. And it has started. What should I do now?
You can do now OC who am I. Okay, OC is the client tool for OpenShift, and you see that you are already logged in as a developer user. That would happen as the start command. You can also switch to the web interface.
How?
Go to the browser. Oh, sorry, you can do it easier. Minishift space console.
Shift console.
Enter. Yeah, there you go. So we are logged in. So this is OpenShift. This is something that's built on top of Kubernetes. If you have already some experience with Kubernetes, you see that it's a bit more application developer driven. Okay, there we are. So what will be the next step for us?
I want to bring my application in there.
Okay, so do it.
And how?
Okay, go OC.
OC. Okay. OC. OC.
Space. New app with the dash.
App.
And now your Git repo.
My Git repo. Okay.
And
that's
return.
my host write service. What's happening now at the background?
Your Wi-Fi is slow.
You think so?
It seems so.
It's there.
Can you stop using your laptops and mobile phones, please?
Ah, yeah. Ah, but it's there.
Is it there? Okay, good.
So we mean we just need to be patient, or what should
Something
happen?
should have happened already.
Should I
Try, yeah.
look somewhere here?
Yeah, it should. You will see something here once it happens.
Ah,
Oh, there we go. There we go.
what happens?
Haha, a lot of magic happened. That's why it took a bit longer and slow Wi-Fi. So Yeah, I guess you had a Jenkins file in your repo, right?
Yes, I had a simple Jenkins file there.
Okay, so because there was a Jenkins file, uh, OpenShift saw there's a Jenkins file, so it provisioned Jenkins for you and started a build pipeline based on the Jenkins file. Can you switch to your Jenkins file?
To my Jenkins file. Okay, my Jenkins file is right here.
Okay,
Can you read it?
at the back. Can you read it? Yeah.
Yeah. So this is my Jenkins file. Yes. It builds with Maven, and that's all what it does. And actually, I have put skip tests here because I don't know how to provision a database.
Okay, that's fine. We will do it eventually. Can you go to the web interface again?
So that's not the right one. This one.
Yes, and go to pipelines.
Pipelines.
And,
Ah.
hmm,
Pipelines.
Okay.
Pipelines.
Okay. So there is some kind of race condition bug. You need to cancel this build. So go to build one,
Okay.
cancel build, and yes, exactly like that. So now we scheduled a second build.
And I can view the log for whatever that means.
That means that you will be switched over to Jenkins and you will be able to see how OpenShift is running the build of your application inside the Jenkins instance that was provisioned. The biggest difference between a clean Jenkins that you would provision yourself and this one is that we already inserted the OpenShift plugin. So Jenkins and OpenShift has a way how to communicate with each other, so they can link things together. So you see that there is something happening over here. There is a pipeline.
Okay, this looks like a usual Jenkins console. So once again, you said when the cluster saw my Jenkins file, it has provisioned Jenkins instance for me. It scheduled a build, but it didn't work because it was the first build. And I have to trigger it manually. And now it's just building what was there in the Jenkins file, right?
Exactly.
That's actually very nice. It's running the build with skip tests.
And if you switch over to the web console of OpenShift again, you will see that there is a pipeline over there.
And
So
it succeeded already.
it's the visualization of what was in a Jenkins file, and you see that all the steps finished because you skipped the test.
Okay, but this is actually not all I need. As I said, my customer wants me to run this as DevOps, and how do I do it actually? You said I need probably I need an image because Kubernetes is image based, right? And how do I produce the image out of this?
So you would be producing the image using something called Maven Fabricate plugin, and you can switch to the next version of the Jenkins file.
Here, reset hard. Ah, that's the next
There we
version.
go.
Maybe we just compare what it changed.
It's a bit longer than the previous one.
Okay, what's in there? Let me interpret. Maybe maybe I understand something. So I don't understand this. What is OpenShift? That's an object. Jenkins file is a Groovy-based DSL. And how does the DSL know what is OpenShift? What's that?
So essentially, OpenShift is the materialization of the OpenShift plugin. So if you are using this object, you are actually communicating using the OpenShift plugin with OpenShift.
And how did the plugin get in?
That's what I mentioned before. It's because you provision the Jenkins instance through OpenShift, we already injected the plugin inside the instance of Jenkins. So it's very smooth experience.
Okay, so I can understand this as a cluster client basically, right?
Absolutely.
And I can do some operations with the cluster using this object that is somehow there, okay? And what am I doing here? Ah, here is new app. That's something similar as I did before, but now there's not a Git repository, but something else. What's this?
So you essentially deploying a Docker image from Docker Hub, from the CentOS organization, from the registry from the namespace Postgres 95 CentOS 7 with the latest tag, and you are putting some environment variables in there, so the database server knows how to configure itself when the image starts. And there is the name, which names the object that will be created for you.
Okay, so I start the database here, and I'm using some hard-coded user password, and I'm passing them here to my Maven build. We should have started this build to see if it actually works, and it will take some time till it succeeds. So, but actually, I may not push yet because I actually I don't want to work with GitHub all the time because my source code is secret and I don't want to show it to the whole world, and I don't want to pay for GitHub private repositories. Is there a way to get a private repository inside the cluster?
Definitely, you can. By default, we don't. OpenShift doesn't provide you with Git repos, but it's pretty easy to provision something like Gox or GitLab, which are open source and can run on top of the platform. So if people want to have Git repos hosted on top of the platform, they just deploy one of those.
Okay, what else do I need to start with a real pipeline?
You need the Jenkins, you need the source code, you need, and in your case, when you don't want to pay for the GitHub repos, you need the self-hosted Git hosting.
Okay, so I see you provided some script that does all these preparations for me, uh, including the internal Git repo and so on, and the script is there in the repo that we shown
Yes.
previously. So let's assume the internal Git repo is there and I can push my code there.
Yeah, let's try it.
So git push minus shift and
Can you read it
force.
from the back? It's hard. It's gone.
Let's look what happened in the cluster. So these are the projects that we have created. This project, one of the project is called CI/CD. Okay, I can see Gox, that's probably the Git repository inside the cluster. This is some storage for it. And I see there is a pipeline that already passed. Okay, we have to log in again into Jenkins.
So you have essentially deployed a new Jenkins inside that project, different from the first one. So it's that
And
easy.
here in the output, we should see somehow that the Jenkins inside the test is communicating with the freshly provisioned database. The output is quite long, but
There is
here
Spring Boot.
the container Spring Boot is starting, and somewhere there we should see some database communication. I think
It's
we
long.
can just believe that it happens. This we can we can see
Hibernate.
some selects and so on. This means the database is there, right? What's next?
So you have essentially deployed Git hosting, you have deployed Postgres to back it up, you have deployed Jenkins, and you run your pipeline through that Jenkins using the Git source code hosted inside your cluster. That's what happened just right now.
Okay, I have switched to the next stage that you prepared for me, and I have pushed it to the cluster. And now inside the cluster, I'll just start the next build. And while it is building, we can perhaps show what it actually does. So let's compare the Jenkins file, what has changed there. So I can see you have added a new stage.
Yes, I did.
And at the beginning of the stage, you are invoking some Maven plugin. What's that actually?
So that's Fabricate Maven plugin. What it does is it helps you to communicate with OpenShift or Kubernetes from Maven. And in this case, it would take your source code, upload it over to the platform, and through the Jenkins, it would invoke something called source to image, which is a tooling inside OpenShift that allows you to build images from source. That's why source to image. So you see that you cannot see it here because there is a configuration somewhere else, right?
Configuration. So I may configure the plugin to do something special for me, right?
Yes, you can.
Well, let's have a look. Because plugin configuration usually reside inside POM XML, okay, and these are the changes in POM XML.
Yeah. So over here you see that there is a profile on the top, which is OpenShift. So this profile is enabled by default OpenShift. So you can have different configuration from different environments. Then there is a lot of other stuff, but you want to see the name with the percent G.
Name,
Yes.
this one.
Exactly.
What's that?
That's how you generate the name of your image. So when the image is created, it will be named like group slash some name artifact and then a tag. So this is the Docker stuff. When you build a Docker image, it will have this name, and it will be pushed over to the internal registry that's running in OpenShift. So if you have Docker images, you want to distribute them, you need some kind of registry. So OpenShift by default has a registry in there. So you essentially run the build, you give the build the source code, it does all this kind of stuff, and once it's finished, it will be pushed over to
once
the
again,
registry.
So inside the cluster, I'm running a Jenkins instance that creates, that builds an image, and the image is pushed into the cluster's internal Docker registry. Okay.
Yes.
And that's how the cluster elements see the image. Okay.
Yeah.
So and this is the name under which other parts of the cluster see the image that I have built. And how do I tell the plugin what's there in the image? And it's probably here the assembly.
Exactly.
And I assume the assembly is just the usual assembly plugins assembly that each of us actually knows.
Pretty
and
much.
Here the port and shell, that's the usual Docker stuff that you probably know already. Okay, and except for that, we have added the failsafe plugin to run a true integration test against the running container, and this is the test. So as you may have noticed, I have pushed it. As you may have noticed, I have triggered a build, and the build succeeded. So this is the new integration test that was run against a container that is based on the image that we just built. Nice. Good. What's next?
What do you need?
What do I need? I have the image. I have tested it. I probably want some way to see it working, to play with it a bit, and I need a real production.
Okay. So what people sometimes do, like it's not something that you have to do. It's a good practice. So you can have multiple stages in your Jenkins file. So one would show you a running application like a QA that you can click through, and then have a manual validation like click this button and then I will propagate this to production, right?
So let's look at the changes in Jenkins file. As you said, you have added new stages. Okay, there's stage called stage and stage called production. Right? In stage, I am provisioning a database again. Okay, and I'm tagging. I am tagging, and let me guess what it means. It probably means that I take the image I have built in the previous step, and I am somehow storing it under a new tag called stage.
Correct.
Okay, and then I'm calling new app with this new tag. Right?
That's correct.
So, and
But also look at the if that you have there.
if this one.
Yeah. So if the deployment, the DC is a deployment config, if the deployment doesn't exist yet, create a new deployment. So we deploy the Postgres database. Sorry, we have the database already. That was the if before that. But now we are deploying just the service if it doesn't exist. And if you check the else branch of this script,
else here,
nothing to do because deployment config already exists. And the deployment config has something called trigger. The trigger can monitor images in the Docker registry. And when there is a new image for that particular name and tag, it can trigger a deployment of the application. So in the first step, when you run the pipeline for the first time, it will create the deployment for you. And whenever you do the following steps, following runs, it only retags the image that was built in the first step, call it stage, and the deployment already is there, and it sees like whenever there is a new image for this name, do the redeployment. So you don't have to redeploy it every single time. Just refresh the image when it comes.
Okay, I see. Would this work on plain Kubernetes?
No. Plain Kubernetes doesn't have something what we call image streams, so it cannot track images in time. It essentially, when you trigger deployment, it deploys whatever is there. It doesn't have a more deeper knowledge of what's directly in there in kube, in the image, so it wouldn't work. The triggers don't work. Those are OpenShift specific.
Okay. So then, what we do? Okay, there's some input. Input. I know input. That's a construct from Jenkins files, and we just ask the user for approval if he wants to proceed. And what we show to the user is if we want this staged image to be promoted to the production. Let's have a look into the log of Jenkins. Oh, we have not started it. What a pity. It will take some time. As long as it runs.
Can you switch to the web interface of OpenShift? Yeah, it's still going there. Okay. So the progress can be tracked from here, or can be tracked from the log inside Jenkins.
As long as it reaches the approval, we can have a look what happens in the production state. So once again, we provision a database first, and then we actually use the same technique again, meaning that we take the stage tag and we store the same image under a new name called production, and we create the application of the production tag inside a dedicated production project. Okay, and once this is ready, the cluster or the log of Jenkins doesn't ask, it just tells us that the new image is there in production and shows us the URL that we can click in the log. So let's look what happened in the Jenkins log. It's building. It's probably the old version. Never mind.
Did you push the Git?
I probably haven't pushed, which is my fault. And I won't be pushing because we would lose quite a lot of time. We will see the manual approval in next steps again. So let me switch to the next version of the demo project. We are there that we are able to click through the application in the staging environment.
You have to trust us.
Yes, we are cheating a bit, sorry. We are able to promote manually, and we are there in production. We have production environment where the application is working, hopefully. And if there's something wrong, I don't have any choice to switch back easily to the old working state. But actually, as we all know, there are quite well established strategies to handle with this. One of them is called blue-green and blue-green deployments, and I have a slide. Uh, what it means basically that we have two versions of the application. One of them is the old one, which is considered stable, runs for some time, and the new one that just needs to be proven in production. We just label these two states of the application with two different colors, blue and green, and we have some element. We need some element in the infrastructure to switch between them. So, Marek, what's the element inside Kubernetes that can switch?
So in Kubernetes, it will be a bit different. What we would do is to use the OpenShift element, which is called route. So the route is going to be pointing at a service. Service is something that whenever you do a deployment, it will create, let's say, a proxy that has a stable IP address, a stable entry point to our application. So whenever we have blue or green, we will change the service that our route should be pointing at, and it will send the traffic to the other one. So the thing is, with blue greens, you do that or that. You don't have a split. You always do 100% on one side or 100% on the other side.
Okay, let's check that we are on master. Let's check that we actually push to mini shift. We have pushed to mini shift. Let's go to builds and let's start a build, and hopefully now it will build what we want to see.
Let's see.
Yes, we can see here the commit message, and it said that it's the blue color first. But how have we done that on the level of Jenkins file? So let's compare the Jenkins file with the previous state again. Here we are doing some scaling. What's the reason for that?
You are using Java, and you have only some limited resources on your machine. So we are effectively, once you go through the staging part, we scale it down to 0, which is like idling. So there are no instances of the application running. So we can save some memory, some resources.
Here we are scaling to 0. And at the beginning we are scaling to 1, and the reason is that all containers are running on this laptop, and we don't want to have too many running at once. So we are idling them, those ones that we create in these two first stages, and the change is not related to blue-green deployments. Okay, but now let's see what has changed really. This is in stage, which is still not so interesting. The main change is in production. And in production, I first figure out what's the current color. And the current color is stored there in the root. And as Marek said, the root is the element that is able to switch the traffic between two versions of between two distinct deployments, let's say.
Let me just say, if I can, by default, everything that runs inside OpenShift or Kubernetes is on the internal network, so you cannot reach it from outside. It usually can reach outside from the cluster, but you cannot go easily inside the cluster. So that's why there is something called routes or ingress or something that allows you to bridge the outside world with the internal world, allows the communication from outside of the cluster inside the cluster to our applications.
Okay, so now we are going to work with those colors, blue or green. We are running this for the first time, so the new color should be blue for us, hopefully. Here the tag step has changed because now we are using the colored version of the image name.
The names are essentially freeform. Well, not 100% if you want to deal with all the security aspects that OpenShift provides. But in Docker world, you can freeform, like name it as you
So here in this case, I create a blue tag, and I create the blue deployment here with the new application command. If it doesn't exist, if it exists, here again, creating the tag would trigger deployment of the application and rollout of the new version of the image. Here I am scaling to 1, the blue color, the new one, and here delete. I am deleting the colorless deployment that I had previously, just to demonstrate the production state. And here I am doing the switching of the root. If the root didn't exist previously, I just create it with the new color, and if it existed, I'll switch the color to the I'll switch the target of the root to the new color, right? And I'll show the user what's the URL of the freshly deployed application. So now we see the real stage, right? It's asking us if this is good enough to be promoted to production. If I click on this, it will show me what is staged. Staged is blue, and production should be still, sorry, production should be colorless. So I change this to prod. Oh, prod is not there.
because you didn't promote it in the first step.
Ah, that's why, you see. Okay. So I should...
So over here you can see that the integration between OpenShift and Jenkins actually is on the input level as well. It just gets you directly to the page where you can do the manual step in Jenkins directly from the web interface.
Okay, so we are cheating again. Imagine that there was a colorless background, white background, in the production originally, and it failed. Ah, well, what's this? It's probably that the step before wasn't done properly. I think we must stop cheating and do the stage prod properly, build it, and then the blue-green should work, which will take us some time.
Do you want to give some time to questions now? Or
Yeah, that's a good idea.
are there any questions in the audience? I'm not sure how it works with the mics.
It's alright. We got a little bit feedback for it.
Any questions? I cannot see the middle side because there is strong light. No. Okay, yeah.
So, if I would have installed OpenShift on my own 2 or 3 servers I have in the States, what is Red Hat offering that's basically missing from this free version of OpenShift that I will find out later, and I mean, maybe be in a bad mood because if I would have known that before, that yeah, I would have made a different choice.
Yeah, so OpenShift container platform is the product if you go into production, let's say, and OpenShift Origin is the open source project that the product is built from. All the development, all the features are in the upstream, and then we productize it in the platform. So essentially, if you do go with the open source, you get all the features. What you don't get is the know-how, support, etc. from Red Hat. So you will be on your own, or community-based support in the production. Red Hat, as the biggest or one of the biggest contributors to Kubernetes and Docker, so and kernel. So we know, like we have knowledge and expertise through all the stack from top to bottom. So we can help you there if you have problems. That's the biggest value. Plus certifications and you know courses and teaching you how to do stuff help you when they get stuck. Feature-wise, if you go with the open source version, it will be fine. Like there's all the features are there.
Okay, I think we have total bad luck today. The demo
Really?
gods are against us. So I think we just stay with the material we have here in the demo repository and stop provisioning because it simply doesn't work. So we were here in the blue green, and we had a switch to green prepared for you. That's here. And a switch to green consists just in changing the background of the index HTML page, and when we run it, it should actually show us that we have switched to green, and we also wanted to show that we can switch back to blue. But because the blue didn't work, the switch back to blue wouldn't work either, because in the cluster there's no working blue version. uh, I may, but let's say let's go to Canaries, and I'll try to reset my cluster into the state where Canaries may work. So reset the repo, and we can show some theory. We have to we haven't named these ones. When we do blue greens, we are switching all the traffic at once, and there are two well-known problems with it. First, the new deployment must be able to handle the database schema changes somehow, and the same must hold for a rollback. So if we roll back from blue to green, back and forth, all versions of deployments must be compatible with all versions of the database schema, which is not always easy to get, but maybe Marek, is there some trick that Kubernetes or OpenShift can help me in this situation?
Well, if your changes are not compatible, you will not be able to freely move. So what you can do is effectively, when you have incompatible changes, like reset the state, move up, and then do rollbacks only after the incompatible changes, and do those in some special ways. OpenShift and Cube, they have when you are deploying the containers, you can also add something called mid deployment. On OpenShift, you can do a mid deployment hook, which allows you to do something in the middle of your deployment. When your containers would be down, you can do migration, then they would all come up again, which is one of the ways how we can help there. But with the blue greens, or if you want to do something more fancy, usually it's good to be stateless application. Like have no state in the application, outsource it to somewhere. Either have the sessions have some distributed cache or something, databases to be backward compatible, etc., etc. Most of the things have been covered years back in 12-factor applications. If you follow those, you will cover most of the problems that you will have.
Okay, and when it comes to database schema changes, you should definitely read Edsson's book. I mean, Edson Yanaga, that is supposed to have next session now. And he has written a whole book about it, and there are many small details in the book that you might find interesting. So let me now try to bring my cluster into the state that would be able to to digest the canary change, and I have somewhere a script here that deletes all objects that might be there hanging. So I'm still there as a developer, and I'll delete all deployments and services, and probably this would allow me to run the build that
Don't do this in production.
not fail. Okay, I'm on the right revision here. I'll push to the cluster. And in the cluster, I'll trigger the next build. And I'll pray to the demo gods that this will somehow work. While it's running, let's have a look at how we do canaries, actually. So, with blue-greens, all the traffic were either there or there. With canaries, we are gradually rolling out the new version. At the beginning, there's just a small part of the traffic sent to the new canary, and the rest of the traffic goes to the original stable deployment. And we are observing the canary for some time, how it behaves, and if it's passing our checks, we gradually increase the amount of traffic that is going to canary up to 100%, and in that moment the canary becomes original, stable, and we can try a new canary. Okay, what it looks like in the Jenkins file, you just compare again. We are skipping tests so that it runs faster. We are skipping the integration tests too. And probe here. Marek, what is probe?
So in this case over here, it's a health probe. So liveness and readiness probes are there directly in Kubernetes that check if the container is still up and ready. If it fails to do one of those probes, it will be restarted or somehow handled based on the state that it actually is in. So the readiness probe checks if the container is already up and running. So it will not be connected to, like, it will not be allowed to receive new connections, new stuff until the application is up. So you can, because, like, I don't know, Spring Boot, I'm not sure how fast Spring Boot is, but some Java application servers, they have long startup time.
Okay, let's shorten it because we have no time.
Okay.
I have implemented a special health endpoint that is cheating. It's returning what we need for the sake of this demo, and in this revision it's always returning 200, which means success. Basically with canaries, it's up to me as a Java developer to decide how I will describe, how I will assess that my application is healthy, and in this case I'm fully cheating, it's healthy all the time. And here further there's a loop that checks the health of the new deployment, and if it sees 200 for like 20 seconds, it checks 10 times and waits for 2 seconds. It considers the deployment stable and promotes it to sends 100% of the whole traffic there. At the beginning we are splitting the traffic 50-50 to the new and old, and at the end here we are sending 100 to the new if this succeeded, right? And
this is a hack. So this is something good for demos. If you go into production or do something real work, you definitely want to do something more rigorous, how to determine if your canary is alive. So you would be monitoring, getting metrics from your application, and based on that you would actually make the decision, not if your application gives you for 20 seconds 200, right? That's good for liveness checks. That's not good for promotions.
Okay, as you can see, the build failed in the middle, not where it was supposed to. I'm sorry about it. We are out of time. please check the demo in the repository. Uh, these are basically things we want you to remember from this application, from this presentation. There's Minikube Minishift for starting experimenting. You can deploy it on your laptop, and if you take care how many containers you are running, you can do nice things with it. There's Jenkins pipeline that is considered a first-class citizen on OpenShift, and it's unfortunately not the case on plain Kubernetes. And Jenkins file is powerful enough to script your own deployment strategies, however you think it out for you. And the source of this demo is there. Thank you.
Thank you.
And sorry.
There is still time for a QA if you want to